In the previous video, we looked at building function compositions for data processing. In this video, we will build a pipeline to take the input, feature vector, and select the top k features, and then classify them using a random forest classifier. So this video will focus on building machine learning pipelines. The scikit-learn library has provisions to build machine learning pipelines. We just need to specify the functions, and it will build a composed object that makes the data go through the whole pipeline. This pipeline can include functions such as pre-processing, feature selections, supervised learning, unsupervised learning, and so on. In this video, we'll be building a pipeline to take the input feature vector, select the top k features, and then classify them using a random forest classifier. We start by creating a new Python file, pipeline.py, and importing these packages. Let's now generate some sample data to play with. So this line generates 20-dimensional feature vectors because this is the default value. You can change it using the nFeatures parameter in the previous line. So here we insert the nFeature parameter and we assign its value to 20. Our first step of the pipeline is to select the k-best features, and before the data point is used further, in this case, let's set k to 10. The next step is to use a random forest classifier to classify the data. So this is the code we've used for it. We're now ready to build the pipeline. The pipeline method allows us to use predefined objects to build the pipeline. We can also assign names to the blocks in our pipeline. In the preceding line, we assign the selector name to our feature selector and ref to our random forest classifier. You're free to use any other random names here. We can also update these parameters as we go along. We can set the parameters using the names that we assigned in the previous step. For example, if we want to set k to 6 in the feature selector and set the n estimators to 25 in the random forest classifier, we can do it with this code. Note that these are the variable names given in the previous step. Let's go ahead and train the classifier. Next, we predict the outputs for the training data. Then we estimate the performance of this classifier. Now we can also see which features get selected. Let's go ahead and print them. So in the preceding lines, we have done this too. Now let's run the code and see the output. The advantage of selecting the k-best features is that we will be able to work with low-dimensional data. This is helpful in reducing the computational complexity. The way in which we select the k-best features is based on univariate feature selection. This performs univariate statistical tests and extracts the top-performing features from the feature vector. Univariate statistical tests refer to analysis techniques where a single variable is involved. Once these tests are performed, each feature in the feature vector is assigned a score. Based on these scores, we select the top k features. We do this as a pre-processing step in our classifier pipeline. Once we extract the top k features, a k-dimensional feature vector is formed, and we use it as the input training data for the random forest classifier. So we got the score here as 0.95 for our data, and this is the k feature vector. In this video, we took the input feature vector through a pipeline. Also, we selected and classified the k features. In the next video, we'll use the nearest neighbours model to make a decision based on the number of nearest neighbours in the training dataset.